All right, welcome back everybody. Today we're going to be talking about standard GQ2, which is graphing quadratics. Today we're going to get into the details a little bit more as to how we actually graph these things. Yesterday we were looking primarily at different parts of these quadratic functions, but today we're going to get into the details of how do we actually produce these graphs. So coming over here and looking at our first one, we have a couple of review problems that we want to consider. Now, right off the bat, this is a line, and we should be able to look at this and identify that right off the bat. But how do we actually graph that? Now, there's multiple ways to do it. Lines actually had a unique trick where you could sit there and as long as you knew the y-intercept, you could put a dot right there. And then as long as you could use the slope, up 3/2, you could generate other points that would fall on that graph. Now, a couple of things to know about this is this is not the only way to graph. Other ways to graph might actually involve coming over there and plotting points. So if I wanted to do this, for example, you could pick whichever points you want, but normally you pick points in a variety of places. But let's just pick 0 to start. If you take x equals 0 and you plug it in, it will generate the y value that goes with that x value. So coming over here, 3 times 2, or 3/2 times 0 minus 4. Anything times 0 is 0. 0 take away 4 is -4. So we know the y value that goes with 0 is -4. Now on our graph, you'll see that that point happens right here. If you pick the point 1 and you plug that in, 3/2 times 1 minus 4. 3/2 times 1 is 3/2. And if you take 4 away from 3/2, it's a little bit of a harder problem since there's a fraction, but our calculator can handle it too. 3 divided by 2, let's put that in parentheses just to be safe. And if you take away 4, you get -2.5. Now, coming over here, -2.5, we can see that when x is equal to 1, and y would be at about -2.5, right? So this point, it actually shows up exactly where we expect it to be. Now, that process would continue. For any x value you decide to pick, it's going to produce a y value when you plug it in, and that y value is going to end up showing up on this line that we've already graphed. Now, the reason this is important is because not everything do we look at and say, I know exactly how to graph that. So, for example, we have this exponential over here. Now, if you're like, I don't know how I would graph that function, it's easy. We can just literally pick values and test them. So if I were to pick x equals 1, all I would need to do is take this function and plug 1 in where x is. 2 to the first power is 2, and 2 times 3 is 6. So when I come over here, when x is equal to 1, y is equal to 6. So that would give me a point somewhere along the lines here. And here's the thing about it. We could pick any points we wanted. Let's just put that there. Let's pick a point on the other side. So if I pick 0, y is equal to 3 times 2 to the 0 power. I'm just replacing where the x is. 2 to the 0 is just equal to 1. 3 times 1 is 3. So when x is 0, y is 3. So when x is 0, y is 3. And we can actually graph any functions we want. Let's do one more. So let's pick the point 2. If you plug 2 in, you're going to have 3 times 2 to the second power. 2 to the second power, this piece, of course, becomes 4. 4 times 3 is just 12. So when x is equal to 2, y is equal to 12. And what's going to happen is if we were to graph more points, we would start to see our function turn like so. Now, here's what you need to know about that. What you need to realize is that we can graph functions that we're not familiar with just by plugging in x values and figuring out where the y value associated with that x value belongs. So let's get to one of our quadratic functions. Now, there's a special way we like to do this because quadratic functions can kind of appear all over the graph, and we always want to identify where that vertex is. So, in order to find the vertex, this is what we're going to do. So, to find the vertex, we are going to make use of a special formula that is -b over 2a. And what this formula is going to produce is this is going to tell us where the x-coordinate of the vertex lies. Okay, so where it is. Now, this uses a's and b's, so we want to always rewrite our function to make sure it has an a and a b if it doesn't. So in this one, we'll have 3x squared plus 0x minus 6. So a is, of course, 3, and b is, of course, 0. So plugging this in, we would have negative 0, because that was the b value, over 2 times 3, because a was 3, right? This is a, this is b. Now, coming over here, we're going to have negative 0 times 6, because 2 times 3 is 6, and 0 divided by 6 is actually going to be 0. So when we come over here and we try to graph these, we're going to take whatever this value is, and that's going to be the one that we put in the middle of our table. So we're going to start with x equals 0. Now to get the other values for our table, we're just going to increase it. So 0 plus 1 is 1. The next one higher would be 2. And then we're going to go backwards in the other direction as well. Now to get the y values associated with these points, we simply want to come over and plug them in. So here's how we're going to do that. So plugging into our original function, so we're going to have 3 times 0 squared minus 6. And that's going to spit out a y value. Now our calculator is really helpful to this, just because it kind of takes a lot of the thinking and errors possibly out of it. So coming over here, I'm just going to type it in, 3 parentheses 0 squared, and then I'm just going to say minus 6. And when I do that, I get negative 6 that comes out. Now we can repeat that process, only now we just want to change, whatever was in the parenthesis to a 1. So when I plug in 1, I would get a negative 3. When I plug in, I'm just going to grab it again and change it again. If I put a 2 in, I would get out a positive 6. Now we can do the same thing with our negative values as well, right? We're just plugging those numbers in. You could do this by hand if you chose to. So if I did a negative 2, because that is on my list, negative 2, I would get a positive 6 out. And if you plugged in a negative 1, so just changing this to a 1, I would get a negative 3. Now the process for this, right, I literally just came over here and I just plugged in these values multiple times. So that's what really goes in here. This is like the work to show that we're plugging those in. Now, once we get those values, it's always important to remember that the x value and the y value form a point. So we're going to get the point negative 2, positive 6 here. Looking at the next one, negative 1, negative 3 would give us another point. And then so on and so forth. So 0, negative 6, 1, negative 3, and 2, 6. Now, once you have those values, you can actually make a graph of this function. So coming over here, negative 2, positive 6 would give us a point right here. Negative 1, negative 3, or negative 1, negative 3 would give us a point right here. 0, negative 6 gives us a point right here. 1, negative 3 gives us a point right here. And 2, 6 would give us a point right here. So you can see your parabola coming through. Now, it's important that we kind of make these have a U shape. These do not form straight lines, right? If you make a straight line, you're never going to hit both of the points. They definitely have to have some curvature to make sure we're hitting those. Let me do better than that. That's not good either. Let me try one, maybe the top down. I can do it. Oh my gosh. I'm struggling, kids. That might be as good as I can get right now. So there would be my graph, right? And we produce that. Now, when we look at the graph, we can find our vertex. Remember, our vertex, we've actually already found it, whether we knew it or not. It comes from the center line. So remember, when we did this formula, negative b over 2a, this gives us the x-coordinate of where our vertex lies. And as soon as we plug that back in, like we did right here, whatever y-coordinate comes out, this piece here is the vertex. So if you're following my pattern exactly, you should always produce that vertex like so. So 0, negative 6. Now, you should also be able to look at the graph here and identify that our vertex is located right there and grab the point from there. Remember, our y-intercept is where do we cross? The y-axis. The y-axis, of course, is this line right here. So where did we cross? It looks like we crossed at a negative 6. So this will be our y-intercept. So our y-intercept would be negative 6, or remember we can write this as a point, 0, negative 6. Now our x-intercepts, you might notice, are hard to tell. They're in the middle. We don't know exactly where those cross, so we're going to have to do more work to find those. We can answer a couple of questions before that, though. This graph, of course, opens upward, so we'll say it's concave up. And the line of symmetry, that's just that line upon which you can fold it. Remember, for this line, it's always x equals, and it turns out it's always x equals whatever the x-coordinate of our vertex is. So in this one, since our x-coordinate was 0, we'd say x equals 0 there. Now to find our x-intercepts, those are a little bit more work. Here's how you're going to do it. You're going to take your original function, so y is equal to 3x squared minus 6, and you're going to set it equal to 0 and solve. Now remember, when there isn't a b term, right, so we're missing the 0x here, then you want to solve it by taking square roots. So the way you would do that is you would start by adding 6 to both sides. We'll get 3x squared, these two cancel out, is equal to 6, and then we'll divide by 3 and divide by 3, and we'll get x squared is equal to 2. And then to finish it off, remember, to undo squaring something, we want to take the square root of both sides. Don't forget, we always get two answers. This and this cancel out, so I'll get x equals the positive square root of 2, and x equals the negative square root of 2. Now officially, we could punch those in and get the decimal, but those are actually good enough for where we're at right now. So our x-intercepts will be at the positive 2, comma 0, and then negative square root of 2, comma 0, because those are points, right? That's where we are crossing right here. Negative square root of 2, comma 0. And then over on the other side, we'll have the square root of 2, positive, comma 0, right? Because the y value is 0 in both of those. So we found those intercepts right there. Nice job. Let's look at one more problem, and then I'll save one for homework for you, because I know this is a lot of work, and it's new, and we're trying to process. So let's do number 4 together. Now, in this problem, the way I would first start is you got to figure out where your table is going to start. So the way you want to do that is by using your negative b over 2a formula. B in this problem is 2. So I'm going to have a negative 2, not that, negative 2, right? We're plugging in the b, or the 2 where the b is, all over 2 times a. And a in this situation was 0.5. Now 2 times 0.5 is going to be 1, so I'll have a negative 2 over 1, and this of course will give me a negative 2. Now remember, whichever value I get from doing this formula is going to be the value that I will put in the middle of my table. Once you get that starting value, you want to count up as you go down, so the next number bigger would be a negative 1, and this would be 0, and then you want to count backwards, so negative 3 and negative 4. Now remember, the next part of this, you're going to simply plug those values in. So you're going to take your 0.5 times negative 4 squared plus 2 times negative 4 plus 2, and evaluate that and figure out what that gives you. Now this is probably the part of the process that will take the longest, because as you come over here, you're going to do this 4 more times. Almost there. But in each of these problems, these numbers inside the parentheses are going to be changing. Negative 4 was only the x value in that top one. So this will be negative 3 here, and negative 3 here. Negative 2 here, negative 2 here. Negative 1 here, negative 1 there, and 0 here, and 0 there. Now we just need to go and use our calculator to punch all of these out. So 0.5 parenthesis negative 4 to the second power plus 2 times parenthesis negative 4 plus 2. So when I hit enter, I get a 2 out of there. So that, of course, is going to give me the point. Let's use a different highlighting color. Negative 4, positive 2. So negative 4, positive 2. And then we're going to repeat. So I'm just going to try to grab this again. And now they change to negative 3s. So I'm going to replace this and replace this. If your calculator can't operate this way, then what you're going to have to do is literally retype that in every time, which isn't fun, but it definitely still works. So negative 3 and 0.5. Now I'm going to make those into negative 2s. And when I do that, I get 0. So I get -2, 0. Remember, the middle one always is going to tell us our vertex. So our vertex will be at -2, 0. And then we'll continue on. Let's do that with a -1. And I get 0.5. So I get -1, 0.5. And then coming over here to the last one, if we delete this out, oops, I'm going to put a 0 and a parenthesis. Right? You just got to be careful about how your calculator works so that you know what's going on. And we get a 2 over here. So 0, 2. Now, I don't know about you, but there definitely is a pattern here that's going on the table. If you see that pattern, you can often take advantage of it to make your life easier, but you need to test it out to figure out what's going on. So graphing those points, -4, +2 will give me a point right here. -3 and 0.5 will give me a point right about there. -2, 0 gives me a point right here. -1, +0.5 is a point right there. And then 0, 2 would give me a point right here. So we want to just produce our graph. Let's see if I can do better than the last one. So there's our U, and there's our U. Coming through, we see our parabola. Now, again, your vertex, we've already identified it, but that's that low spot or that high spot. That's always this middle value once we get done with this, as long as we use this formula to get us started. So my vertex will be at -2, 0. My y-intercept is where do we cross the y-axis? It looks like we cross right here at a +2, right? So my y-intercept will be either we will say 2, or we will also use the point often and say 0, 2. Now, a couple things to realize. Remember, we talked about this on day 1. Our y-intercept is always this value. So you can sometimes just jump without even looking at your graph to identify that. Right, that 2 also shows up there. Now, before we get to our x-intercepts, let's talk about the concavity. This one opens upward, so we'll be concave up. And our line of symmetry that divides it in half will come right down the middle. So this will be x equals -2, right? Because that is where we are hitting. And remember, it's always x equals whatever the x-coordinate of our vertex is. Nice. So let's carry on here now. So looking at our x-intercepts now, this is the last part. It's often the hardest to solve for. You want to take whatever your function is here, and what you need to do is come over and find a way to solve that. Now, since there's the 0.5 in there, I think factoring this is going to be kind of tough. And we have to factor because we have this middle term. We can only use square roots if we don't. So I'm going to suggest using the quadratic formula. So I'm going to start by just recopying this formula down, or the original down, so that I can see it. So let's try to do this. So coming on down. Remember, my quadratic formula is -b. So this is our a, this is our b, and this is our c. So we'll have a -2 plus or minus the square root of 2 squared minus 4 times a times c. A is, of course, 0.5, and c is 2, all over 2 times 0.5. Now, when we enter this in on our calculator, we always like to focus on what is inside the square root first. So we'll have our 2 to the second power minus 4 parenthesis 0.5 parenthesis 2. Let's get the inside. We notice our inside of this is 0, so this will be the square root of 0. So we have -2 plus the square root of 0, 2 times 0.5. 2 times 0.5 is 1, so this is 1 on the bottom. And we do know something about the square root of 0. The square root of 0, if you were to punch that in on your calculator, is 0. So we have -2 plus 0 divided by 1, and -2 minus 0 divided by 1. -2 plus 0 divided by 1 is -2. -2 minus 0 divided by 1 is -2 again. We got the same answer twice, so that will be our x-intercept. Now remember, you can always identify that x-intercept just by looking at your graph too, assuming it's a nice number. You can see right here where your graph touched or crossed our x-axis. It happened at -2. So when we see that, we can use that often to identify it as well. So coming over here, we know that our x-intercept will happen at -2, 0, because that's a point. And in this situation, we don't even have a second answer there. Now, the rest of your homework is going to be finishing up this last problem. Take it seriously. Practice this stuff. I know there's a lot of information here, but try to connect the dots to see what's going on. Thank you guys so much for watching the full video. If you have any questions, please make sure you are reaching out and asking. Have a nice day.